Hello YouTube, we have the beginnings of another Dynaco project. If you look back the last few videos I did, you would see among them a video of the refurbishing of a pair of Dynaco Mark IIIs, right? When I got those Mark IIIs built, I really loved them. I have to tell you, those Mark IIIs sound amazing. They're incredibly clean. The bandwidth goes very high and very low, and I'm really enjoying them. Now, the little difference about those Dynaco Mark IIIs is that they had some modified driver boards in them from a company called CAE, which is Joe Curcio's Dynaco modifications. And I happened to see an option for this Dynaco Stereo 70, which had driver boards from that same Curcio CAE company. So I was very interested in that, and I went ahead and bought it, and here it is. And again, my compulsion to buy this was very much based on my good experience with the Mark IIIs. And if it was a regular Stereo 70, maybe I wouldn't have bought this particular one. Okay? But we have a lot of work to do, because even though this has driver boards that I really may like, the seller did warn me that it's not actually in working condition. This amp hasn't been used in years, and there may be a couple of missing parts and snipped wires and so on. So it's actually, this is a non-working condition. Yet I still bought it, right? Because the value of the ST70 itself and the value of those additional driver boards is certainly worth it for me having to go and finish up and redo the wiring and so on, right? So let's have a closer look. Okay, let's have a first look at the cage. The cage is the original paint on it for sure. It is a little scuffy looking. Unfortunately, something kind of bumped into the front logo and distorted its appearance a bit. And there's a couple of spots where it looks scuffed, like some paint is missing, as if it just rubbed into something. But other than that, it is structurally fine, and there's no dents or holes drilled in it, so that's fine, right? Okay, so looking at the chassis here, we have the regular nickel finish. It's not too bad, but it could use a little polishing, and the front has some pitting. Maybe the front looks the roughest out of the whole thing. Right, so we can see we have problems with the front. There's some rust spots, right? And there is some missing text, right? The rest of it actually looks fine, to be honest. Now, let's look at the very obvious modifications that are present. Okay, first of all, we have this larger driver board, which is on these very high mounts. They look like an inch or even taller, and they sit very high above the chassis. And there's these, I'm not even sure what these are. I mean, they look like capacitors. So this sticks up very high off the deck of the chassis, right? And then also, to what's obvious, is that there's these octal connectors, which were really kind of a waste of time on a lot of Dynacos. Is that Dynaco originally introduced mono amps, so you'd buy a Mark II or a Mark III or Mark IV. Those are all mono amps, and Dynaco used to have a mono preamp called a PAM1, and you can see it. Some of them had it listed here, PAM1. So you would actually have an octal umbilical cord that would plug from the front of the mono amp into the PAM1. And that actually sent high voltage from the power amp into the PAM1, high voltage DC to run the tubes. And it also sent filament voltage, 6.3 volts AC, to heat the tubes in the PAM1. And the PAM1 sent back its preamp signal into the amplifier. Those octal sockets, those connectors, are present on the mono amps, the Mark III, Mark II, Mark IV. Maybe some others I'm not thinking of. But they also included on the ST70, so you could put two PAM1s into here. However, they started producing stereo preamps, the PAS series, PS2, PS3, and PS3X, which were stereo, and they only sent out an RCA cable into these amplifiers, the mono ones as well. And there was no, I don't think anybody, probably 99% of Dynaco users probably never used the PAM one, but they all have these octal sockets on the front anyway. So that's the story of those octal sockets. So these are missing because there's actually another board inside. This big board here is a power supply regulator board, which not all of these modifications come with. You actually buy this top board separately from this bottom board, and maybe most people, maybe I'm just estimating, actually buy this top one without having the bottom one, because without this bottom one you can use the normal Dynaco power supply and filtration or on a simpler modified version. But this one is actually regulating the power going to the bias, the plates, and the screens too. And by regulating screen voltage, it also implies to me at this moment that this amp is not run as ultralinear. Dynacos are famously usually ultralinear, right? I think this may be actually pentode operation with a regulated screen supply. So that's a big add-on. So these two boards, top and bottom, the value of them, plus the actual stock Dynaco parts, these are the original transformers here, right? To me, adds the value for the project, what I was interested in. I wasn't really interested in a regular ST70. I would have wanted to modify it to make it cleaner and more hi-fi anyway. And again, I was impressed with my Mark IIIs, which aren't upgraded as much as this. This is very high-tech. Okay, so you'll see that the original phenolic octal sockets have been replaced with these white ceramic ones. There's two capacitor cans here. Originally, this would have had a socket with a tube rectifier, a 5AR4 GZ34, but that I would have ditched that anyway. I am not a believer of having a tube rectifier in an amp that's 4 EL34s. Not me, buddy. That's Sag City, and whoever wants to disagree with me, that's no problem. Go right ahead. Okay, so I'm a solid state rectifier guy when it comes to maximum power. Okay, over here too, they have something I'm not into, which is these two-way binding posts. I like to use the old original 4-screw spade lugs, right? And here we have a missing power switch too. Now here's the thing. I actually have an old Stereo 70 chassis hanging around here. Here is an old, even more dead, more rusty Stereo 70 chassis that I once started to rebuild, and I just never even finished it off. I don't even know what happened to some of the parts of this amp. Unfortunately, it's a very sad story where I literally cleaned out a lot of junk from my workshop one time, and I actually threw away the bottom panel and the top cage of this in a completely crazy purging out of my my workshop area because too much junk was in there. Anyway, so this has some of the original parts. This has some of these switches. I mean, I'm gonna get brand new switches, but like things like this is the original Dynaco Stereo 70 circuit board. So if this was some big kind of failure and I hated it or it didn't work, I could go back to the original board. Cool. This is not the original transformer. This is actually a chassis that has no transformers because this is just some scrap transformer I have laying around. This has the original speaker connector panels, and I'm actually going to put these right back onto this one here. Okay, so I'll be scavenging a bit out of this to go back in here. Now here's an original power transformer, the PA060. Now there's actually several different versions of this transformer because as time went by, some of them got taller or shorter iron laminate stacks. The shorter ones are 1.5 inches tall, and this one's a little higher. It's actually about 1 inch and 3/4, right? So this is a little better version of the original transformers, and this one may run a little cooler than the short 1.5 version. The modern kind of premium replacements for these would have this iron laminate stack at a little taller than 2 inches on this ruler, maybe even 2 1/8 or 2 1/4. And those all seem to have significantly higher current ratings. For the heaters, especially, there are 2 heater windings. And that extra current capability makes the new ones run cooler. These old ones are notorious for running really, really hot. These appear to be the original output transformers. These bells have been clearly painted gloss. The originals are sort of a greenish gray. I know that there's some parts missing from this board, and there's some loose wires and stuff in here. So what I'm going to do is I'm going to contact the supplier of these boards, and I'm going to see if I could get the documentation for this, because I would like to go through and verify all the wiring of this installation. A quick first look under the chassis, we could see from the output transformers, the older output transformers, or most of them, have these cloth colored wires with the different color codings. You can see some of these are taped off and heat shrunk off, and these are the screen taps that would make the amp ultra linear if they were connected, and you could see they're not connected, so this amp is not running ultra linear. And there's this wire here, right, which goes across the same color, goes across to this socket as well. That is showing that these screens are receiving an regulated voltage from this board. So again, this is pentode operation, not ultra linear. So there's a couple little things like that connect that. What is that? I don't know what that is. So I need to get the original documentation to clear up a few little oddities here. All right. Okay, so I actually reached out to the manufacturer of these upgrade driver boards, which is CAE Electronics, Curcio Audio Engineering. And very graciously, Mr. Joe Curcio sent me all the documentation for these driver boards. It turns out that these ones are a bit older, so we have accurate documentation, right? I've been looking through it, and there's a couple strange little mods I saw which are not from Curcio, and maybe the last owner did it. First of all, there's these odd turrets on the corners of the board. I don't know what that is for. Were they? I initially thought they were test points, but I don't really think so. I wondered if they were turrets for doing quick changes of capacitor swapping, right? Like these big capacitors here, these huge upgrade capacitors here, actually correspond to these terminals. The other thing is I see some jumpers here. There's 4 jumpers, 2 per channel. And when I looked into the manual here, those would have been initially spec'd to be 33 ohm resistors. And where they are in the circuit, clearly they've just been sent to a straight path. And I'm not sure what that would do, but I'm quite willing to go back to the 33 ohms, right? So I'm working up from this, on this manual, I'm also drawing in a list of things to do and a list of parts to buy. So we could actually go through that now, and I'll comment on them, because I haven't done any work yet, but I'm planning to make this as nice as could be, figuring out what is wrong right now, rectifying that, figuring out what may be too old and needs replacing. Like, I mean, this board seems to be from the mid-90s at least. So we're looking at 30-year-old electrolytics. So there's a few parts I want to change already. These 2 as well. Maybe. I'm not sure about the capacitors. We'll come back to that. And then little modifications I want to do, because there's certain things that here that I would have executed a little bit differently. Some of the wiring, and like for quick example, these standoffs are so tall. I'm thinking of putting smaller capacitors on the top here and dropping this height down. This penciled in list is already our project to-do list. Let's go through it. Okay, at the top here, boards need a few corrections. Top board jumpers, bottom board wire rounds, right? So the only mistakes are these jumpers here, and on the bottom power supply board, there's some wire wounds that are looking a bit burnt, and one is the wrong value. One is a 1K, it should be a 200 ohm, okay? New choke, right, that's a whole discussion. So the original Dynaco choke is called a C354. And it is used in the Mark 3s, Mark 4s, and the Stereo 70. They are rated at 200 milliamps, and they're small enough to fit in the chassis. And there it is. The problem is they're rated for 200 milliamps, but the Stereo 70 runs the amp at idle when you haven't even turned on any music yet. It runs more than 200 milliamps through those chokes, right? How does it do that? Well, the bias spec for Stereo 70s from all the way back is 50 milliamps per tube, and that's 200 milliamps, right? Now that includes the power tubes, but there's also a few more milliamps that are being used by the preamp as well. So it's just over 200 milliamps in idle. Okay? When you're actually playing music, there's more current being drawn, right? And you can see it when you read bias. That 50 millimeters that you set each tube to read, right? You'll see that jumping up when music is playing. So now the same choke in a Mark III or a Mark IV is under a lot less strain. A Mark III, which I have a pair of them, I know all the specs, those run the power tubes at 70 milliamps each. So we're at 140 milliamps plus a little bit of driver current being pulled. So let's say 150, okay, at idle. Well, the choke is rated at 200 milliamps. So we're in a much safer margin than what is happening in a Stereo 70, okay? So the challenge is that chokes that you buy are generally kind of a little bigger than this, especially if you're going over 200 milliamps, right? So the problem is you want to buy a bigger choke, but it's not going to fit. This space in here is only 1 3/4 inches, right? Otherwise, you'll have to try and figure out how to mount it on the top, which is kind of ugly looking, right? So there is a company called Triad Magnetics, and fortunately, they manufacture a choke that is 240 milliamps for pretty much the same specs, which is I think this is 1.75 Henrys, and maybe the new one is 1.5. And they're both in the 50 to 60 ohm resistance range. The other Stereo 70, the chassis that we have down here somewhere, I had bought a Hammond choke for it. But this one is still also it fits in the chassis, but that's also 200 milliamps. So that's really the spec of the first one, which is a bit strained. It's a good replacement for the old original choke, but it's not an upgrade. AC wiring to be redone, 3-prong and power switch. This one doesn't even have a power switch installed, and it's set up as the original 2-prong wires. Now I don't go for this. I do 3-prong because I need a grounded, safety grounded chassis, right? I mean, I build amps, I manufacture amps, and I know about the risks if you have a shorted part and the fuse is not blowing because the chassis has gone live instead of being routed off and blowing the fuse, right? So I do 3-prong. I did those on the Mark IIIs as well. Redo socket wiring and remount sockets. All right, so they have some sockets here. I just don't like some of the wiring. I think that they're mounted in. I think the brackets were installed wrong. Okay, upside down. So I'll do that. Bias measure. All right, so these have the original 15. What are they? 15.6 resistors, which is a specialist specialty resistor from Dynaco, and they were designed so that when you measure bias, you want the meter to read 1.56. And the reason they had that was because back in the day, well, still today, a AA battery, brand new, measures 1.56, or it's supposed to, or back then it did. And what that meant was that you could take your meter, back then it would have been an old analog meter with the needle, and you could measure the voltage of the new battery, and you could calibrate your meter from the new battery voltage. You could say, well, this battery is supposed to measure 1.56. So you would hook it up, calibrate the meter so its readout is accurate, and then you would take the meter over to the Dynaco and bias it to 1.56, so they knew that the meter was being accurate. But the design is such that 100 milliamps flows through that resistor when it reads 1.56. So that was the idea, is like we're taking the battery voltage and giving it to you to use as an accurate calibration bias routine. Okay. Now this board has individual bias level adjustments for each channel, and it also has on top here, these blue ones, bias balance. So what we're doing is we're going to be individually biasing each tube. Okay, so via those 4 pots, which is great. So what we need is we need 4 individual bias resistors. So I'm going to do away with the old 15.6 resistors, and I'm going to have 1 ohm or 10 ohm set up for each tube. So I'll have 4 test points, right? And they will be individually adjusted. Restore speaker terminals. Okay, I don't like these 2 ways. If I'm using 8 ohm and 4 ohm speakers, I'm going to want to move between them. I don't like banana plugs. You know, I like these screw terminals that you can push a wire through and clamp down. But I want nothing to do with banana plugs. And I want to get back my old school spade lug setups. Okay, I already bought these terminals that perfectly suit the old spade lug terminals, right? So I'm going to go back to that. New front RCAs. Okay, so the original amps, the RCAs on the front are kind of crappy. Let's have a look at them. Okay, here's on the other chassis. This is the original set of terminals. Now these didn't have much for nickel plating, so they pretty much appear to be worn down to raw steel. And then the other criticism that people have is that they were very close together. So a lot of times you would put a pair of RCA connectors on, and you know, RCA connectors can sometimes have a little bulky jacketing around the end, and sometimes they wouldn't fit together. So they had to kind of grind down the faces or get very specific RCAs to fit these. So these here are much better ones, but they're kind of scrappy looking because they're a bit large too. Now the problem is that this type has, you mount it from the inside and you put this mounting nut on the outside, and it takes up a lot of diameter, right? So you have to, this doesn't have that little board, that little brown phenolic board doesn't have that. It's just the terminals themselves sort of crowded into that oval space. So from Switchcraft, which is the real original old school connectors to deal with, like I buy them for Fender amps and stuff, has a different version of this connector where the mounting nut is on the inside and it uses much smaller holes and narrower diameter layout. So I'm going to buy a pair of those and redo a little phenolic board and have those mounted back on the inside, but at a slightly wider spacing if I can, to make the RCAs fit a little better. Next one, remove tall turrets on the top board. Okay, so I find this is odd looking. this board, like so. All right, so originally these boards are attached. The original circuit board is very well matched to the size of the cutout, and they almost completely flush mount to the inside. And some of the replacement boards have the same size. They have the same floor plan, right? So they fit flush. But this one is bigger, so it overlaps a bit, and of course it has to be elevated off the top. In some cases, sunk below on the inside, but we have two boards, so we can't go on the inside. So we have this top board on the top here, and obviously this guy has put some, last owners put some huge capacitors here, but nowadays we're getting these same value of capacitors in a much smaller size. In fact, here are ones that I have in mind to replace them. And I mean, they're just much, much smaller, right? And they can easily go on top, okay? So I'm gonna take these white ones out, put these smaller black ones on top, buy shorter standoffs here, and sink this board as far down as it could go without anything from here bumping into anything on the inside. I think they have good clearance. So these are 1 1/8 inch, and I even found some little spaces here. How big are these? These are 3/8. 3/8 spaces here, and I can test and see if I can use these. Next one. Make a nice front panel with test points. Well, that kind of gets back to what I was just talking about with the bias resistors. So, I mean, of course, this front panel has some rust spots on it. Okay? It has some missing text, a little bit, right? I mean, come on, it's ugly, right? And as a finished product, the front appearance of this amp with this kit is not very nice, because even I hated those octal sockets on the front. At least when all those parts were in place, they had something of a look. And then this mono stereo switch is missing too now. These originally came in the mono stereo switches. This one is in place. But I mean, we have no use for that nowadays. None at all, right? So what I'm going to do, what I'm thinking is on my CNC machine, I can make a metal or plastic new front panel. And on that, only have mounted what I really need to be mounted. So maybe new front panel with the new RCs here in the front, and then some nice logos like a Dynaco Stereo 70 engraving or something, and nothing else, a clean look. Now I also have to put on 4 test points to test bias, okay? But I'm not sure where I'm gonna put that yet. Should I put that in the front panel? I don't really want to, because again, more holes and more clutter on the front panel. Can I put it somewhere else around the amp? Yes, maybe. So part of that discussion comes to this. Last point, new bias pots and relocate them at the test points, right? It's the same topic really. So this one, this bottom board has the left and right bias level adjustments. And when everything's in place, they are accessed through these same socket holes that I'm complaining about, right? So I want to get rid of all of this front panel action. So what I can do is run 3 wires out of these connectors here and relocate these level controls back to the original position. The original bias level controls were here. Little pots with a screw adjustment, and you take a screwdriver and you'd be doing all your biasing from here down into those pots. So they've relocated these to this front thing. So I'd like to put them right back there, okay? So that when I am biasing, I'm doing level and balance from the top, okay? And less clutter on the front. So that's it. That's my shopping list for now. The last thing I'll cover, which is a hot topic, is what to do about the capacitors. Now, right, so this whole upgrade setup still works with the original capacitor multicam, which is, I think, 4 sections of 30, 20, 20, 20. Okay, so this is a bit on the low side. And the thing is, you're asking, what is this can? Because on an original Stereo 70, this spot gets a socket with a tube rectifier, as you see right here. Okay? So this is a spot where people add a supplementary can if they've gotten rid of the tube rectifier, like me. And this one is 240 sections, and they've been wired together. They've been jumpered together. You can see there. And added to one of these sections, the one that feeds the plate voltage. So what that is basically, it's adding to one of these sections here to boost it up by 80 microfarads. Now that's not a bad thing. That's all okay with me. Extra capacitance is fine if we don't have a tube rectifier. However, I think these cans are 30 years old. They may not be bad. I think I might as well go ahead and change those cans to something with a higher capacitance value and also brand new and fresh, and easy to replace in the future. That's what is running through my mind. One thing that I could do, it is possible if I really wanted to max out on capacitance, I could buy like this. I could buy these JJ cans, which are 100. Could buy another one of these. So 400 sections, and I could take these out and put 2 of these cans, right, in their place, and I would have 4 sections of 100 instead of this, which is 30, 20, 20, 20. This is really inadequate. There is a can that's about the same size that can be bought that has good values. I think people like for Dynacos, which is 40, 80, 30, 20, or something like that. But the key one being the first 2 being 40 and 80. And those are good for the before and after choke. Okay, so during some downtime while waiting on parts to arrive, because it takes quite a while, I have drawn up to be carved into some material on my CNC machine a faceplate that pretty much just blanks off the front of the Stereo 70. And all I've left is holes and a little platform for mounting the RCAs. I don't have an interest in the octal sockets or any test points or something else on the front. No switches or anything. So here we are. I put the Dynaco logo on the top left there. Put some text through with Curcio here. I hope I don't get in trouble for that. Maybe I'll send him a nice email and hope he likes it. And this, I have a few different materials I could try this in. But the first one I'm going for is a sort of a silvery aluminum finish. This is a board that has a thin outer layer of aluminum in between a very hard plastic type construction board. The other one I could try is thin plastic where it's black on top, white below, and you can engrave through the black into the white. And I use those on my amp faceplates. And then also 2 like normal aluminum sheets. But let's see how this goes. Okay, so the first attempt in the silver material that I showed did not happen. That aluminum top layer was much harder than I expected, I think. Too hard for the very narrow, tiny little bit that I was using. And it just broke the bit. And also to the material, it just didn't work out. So I have shifted to the plastic option, right? So we've done our letters here, and now I've set a new bit, which is going to cut the outline and the hole for the RCA jack. This is our new faceplate. Okay, now one area of concern with Dynacos in general and modifying and so on. An area of concern is the temperature of the power transformer. One contributing factor to transformer heat is how much heater filament current is being drawn. Because this is using 4 driver tubes, ideally we should run the 6922 or 6DJ8 smaller 9 pins as the drivers, which use 0.3 amps each. However, reading around on the forums and internet in general about these same Curcio mods, I stumbled on the little bit of info that people tend to prefer 6 CG7 tubes in these amps. And actually I did have enough 6 CG7s hanging around that's what I put in my Mark IIIs, right? And I'm very happy with those. I did compare them and tend to prefer the 6 CG7s. I found that they sound a little fatter in the bass and mids in my listening environment, right? So I've bought a bunch of extra 6 CG7, all used but tests good, and I'm going to be using these 6 CG7s. Now again, this brings a concern that I'm running too much heat, filament heat on the power transformers. So that does bring up a topic I will address in a short while as a potential modification, but this is my nice stash of driver tubes. Okay, finally some parts have arrived. Jeez, these took really long to get down here. Okay, so we have some, well, this is for a side quest project. This is a Hammond box to make one of my pedals. I do pedals. I build everything. I build guitars, speaker boxes, amplifiers, pedals. This one is for a buffered loop box. In other words, the guitar will come in here. We'll send out a signal to a chain of guitar pedals, and it'll come back here, and this will go, a fourth jack will go out to the amplifier, and we'll have a stomp switch. When you hit that stomp switch, you'll dump signal in case any of the pedals are malfunctioning, and you'll go straight from guitar to amp. Now, it's not rocket science, but what we add in is 2 buffers between the guitar to loop signal and from the guitar, loop to amp signal. And that gives us a choice of buffering after or before guitar effects pedals. And this rescued quite a few customers of mine who had complicated pedal boards that gave problems due to losing signal from whatever modern trends of true bypass and so on. Anyway, so these are parts that are mostly electrolytic capacitors, because the ones on the Curcio board now, I don't know how old they are. And then there's a couple of fresh wire wound resistors, and these more slimline RCA input jacks, some feet, some signal caps, bias controls. And that's about it really. And then this big capacitor here. And a new 3-chord power cord. I have a whole scheme I'm cooking up with the power supply capacitance, so we'll get to that, right? So now I get to start tearing into the amplifier. So we'll nickname this the Super 70 project, right? So we're looking for problems and mistakes. I did that already, and I've discussed that with you. Replaced all bad parts, and I've only just gotten, as I said, some resistors and capacitors that I think need to be replaced. And that's it. So now we're ready. Okay, so I kind of thought at first I would only really have to do looking at the existing wiring, making some changes, some modifications or whatever, but going along with the amp as it's built. Okay. However, in reading the manual for this project, for these boards, if in this text here, the write-up here, the composer of this says to go ahead and strip down the chassis and rebuild it, because this is written with the assumption that you're starting with an old stock Stereo 70. Or maybe, you know, in kit form, maybe, right? Initial set of text here is to break down the chassis and rebuild. Right, so in the spirit of that breakdown advocacy, I will strip down this chassis. I'm really just taking off the boards, taking out those capacitors, remount the sockets, look for problems, and generally just do things over the way that I would do it. Okay, so I've earnestly started stripping off parts, and the first thing I did is take off the bottom regulator board. And there's a few little notes, you know, markings of where the connectors are, but I added a few as well. Quick notes, we have these cement resistors to replace, and these should have not been mounted so close flush onto the board. They've caused these burn marks from their heat. And I will say that in the manual it does specify that these should be elevated above the surface of the board. So there's little notes that the original assembler of this did not pay attention to. Also to these heat sinks. Well, alright, so there's a heat sink here and it's flopping around. I can see this is upside down. These things sticking up here are actually the legs that are supposed to be poking down onto the circuit board. So there's little things like that. Also too, there's a bunch of these gold and silver turrets. They're not just randomly added in. There's actually a sort of an appropriate solder pad that these turrets are installed into. And what all they connect to is the main output coupling caps, like these big white ones here, which I'm going to replace. But I don't have to, but I choose to replace them. But I don't like them. They at a funny angle, and they put the part too high up in the air, so I'm going to get rid of them. And then look at this. These are some resistors, and they were installed, real high precision resistors, and they were installed without cutting the leads at all, so they're just flopping around in the air here. I'm going to cut these and shorten them, right? So all of these things are going to get reworked. Okay, so I've enthusiastically been snipping away at the wires, prioritizing keeping the integrity of the transformer leads, right? Which are these old cloth covered ones in the case of the older Dynacos. This kit actually, in the manual again, it specifies please use Teflon wiring. Now I don't want to sound difficult, but I hate Teflon wiring. But I think a fair amount of this wire has been Teflon. But Teflon it's slippery, it's hard to cut and strip back the ends. It's a little difficult to work with. And it doesn't stay in place. Well, this one seems okay. Depending on if it's stranded or solid, it doesn't really. Sometimes it doesn't stay in place when you bend it and stuff. But this seems okay for that. But again, I wanted to put in my own kind of color coding of wires. So, and some of these are too thick. Some of these are really, really big, very large, coarse wires carrying signal that had no current at all on it, right? It's a good idea that I strip down this chassis because, like, for example, look at this here. The grounding of the left pair of power tubes is just simply done by this resistor crimped. Oh wow, and it just broke in my hands. Yeah. So yeah, this is an example of why you rebuild everything. None of the grounding is done properly. Right. So onward I go, having fun just tearing it apart. Another little thing that drove me crazy when I saw it. So these are ceramic replacement octal sockets, and as you can see, they've been mounted with a very long bolt. But I have enough experience in this to know that those brackets are upside down. This little gold colored bracket here is supposed to be upside down like this, so that the mounting surface is almost flush with the chassis. This one has it up in the air, like almost a ½ inch above the chassis. This is ridiculously bad here. Okay, these are all mounted upside down. Small point of interest, I'm wondering if this is the original Dynaco capacitor. I do see some crud where it may be leaking, but it's really the original brand, Cornell AA. It's the original capacitance values. I see up at the top there's a date code that includes the year, the numbers 1992. I don't know if that means this was replaced in 92, but I do wonder if this is the original. So but that has to go. All right, and so this kit is able to be used with the original Dynaco capacitor with these small values, but optimally, I think everybody knows and everybody acknowledges that raising the capacitance values overall does increase performance. In this case here, this is a how you pronounce that? Sprague, Sprague, Sprague. This is a capacitor that has two 40 microfarad sections, which were parallel. And this was added in parallel to one of these sections here to make it 100. So this capacitor is used to boost this up. Okay. Now an observation we will make is that this is rated at 500 volts DC and got along just fine. I have been worrying about the capacitors that I intend to install because I was worrying, I'm still worrying, if their 500 volt rating is good enough. Okay? But here we know that this has been working for years with a 500 volt capacitor just fine. So that could alter my decisions. We'll get to that. I'm not ready to discuss all of that at this moment. But my point is that both of these capacitors are being replaced with ones of much higher value. Okay, in another work session here, I've done a few things. I've taken the octal sockets, which I think are very high quality. The metal used on the tabs here is very, very hard, very stiff. And after retensioning everything and taking off all the old wiring, they have a very strong grip on a true base. So I'm happy to continue using those. On this top board here, I've done a few things. I have reaffixed this heatsink on this regulator chip and added a little of the heat transfer paste as well. I've replaced this electrolytic. This was a 10 microfarad. I've put on a high quality Nishikon 22 because it fits and it's always nice to go up in value, right? And next, I put in Solon capacitors here, which I have good experience with, and it's the best that my regular supplier had on hand. The CAE company does seem to fit Weimer, those kind of pinkish red ones here, the rectangular ones. Okay, next and last really was some of these resistors here, the carbon films, the light colored ones. These are actually replaced with jumpers, and I don't know why, but I've returned it to the value, which is 33 ohms. As far as the mounting goes, I have taken off these pretty tall 1.25" standoffs and replaced them with some reasonably short 3/8 of an inch. So it's not sticking too high off the chassis deck. Next up on the chassis itself, I'm going to just remove one or two more things, and I'm going to just clean it. Basic cleaning, no big thing. This choke is going, I mentioned before, I've bought a higher rated choke. This is 200 milliamps, and I've bought a 240 milliamp one. And it's the same size, so it's going to go here. Okay, I did a somewhat intense work session tonight. I cleaned and tried to polish this nickel chassis as much as I could. Unfortunately, the front is pretty bad. The front has rust spots and stuff, but the rest of it is pretty great, right? So underneath now, let's take a look below. At the inside here, I just kind of wiped and cleaned any residue and stuff that was inside here. I have reattached the old school original style speaker connectors and the appropriate wires. I've put in a new power switch, a new power cord, kept the old original fuse holder, which is fine. And that's about it for now. I'm prepared to put in a new choke. This is a new choke here. And that will go right here on these studs here. It's the same size as the old one with the higher rating. This one will now be set aside as a spare for my Mark IIIs. This is the original C354. My next area of focus here, I have put in a new power cord, and I'm doing a three wire cord setup. So it's a little different from the original because we've got to ground one of these, and then we send one of them, the white one, directly to the transformer, primary, and the black wire here, which is the hot, we're going to send through the fuse holder, then the power switch, then to the primary. However, I also want to include a thermistor, which is used to give resistance and help like cold starts when to limit current when you now switch it on and the capacitors first start charging, right? So that's going to be included. I'm kind of doing a little thinking here that's quite different from the stock setup. Okay, I did a pretty heavy assembly and wiring session tonight. And what I've done is everything that you would do on any Dynaco rebuild. So this is not specific to these mod boards, right? Everything I've done, almost every Dynaco Stereo 70 rebuild has these things. Okay, let's start with the primary wiring. I put in a new power cord, and the 3 wires that come in, I send the neutral straight into the power transformer. But the hot line goes into, I have it going into the fuse, then this thermistor, which is a CL90. I'll talk about this a little more in a minute. Then it goes to the power switch, off and on. And then that goes to the other line of the power transformer. So all of the parts are in line with the hot black wire. Okay? Right, so the thermistor is something to limit inrush current. What it is, it's a part that has a resistance when it's cold, right? I think it's 120 ohms, right? And when current passes through it and it resists that current, it heats up. And as it heats up, it actually drops in resistance. And it goes back down to almost 1 ohm or thereabouts. So what that does is when you switch on the amp and there's a rush of current in to charge up the capacitors, that rush of current can stress out certain parts. It could blow the fuse, it can stress out the power switch and so on. And it's generally more current rushing in than it normally operates on. It's an excessive thing. So the thermistor limits that current inrush and gives you something of a slow start, right? Okay, so the next thing is I've put in the new choke. We spoke about that already. Now on a Dynaco, the original capacitor looked like this. I think this may be the whole original, as I mentioned. So there's 4 capacitor sections, which you see those 4 tabs in the middle there, right? And on the diagram, it's represented right here, these 4 things. Well, this is a different arrangement to the stock diagram. Anyway, but it's 4 sections. So what I wanted to do, I had a bunch of capacitors on hand that I want to use. And they're these types. They're not the metal outside types. It's these ones that have insulated, plastic insulation on the outside of the can, right? And they're all 100 sections. So the sections of this are 30, 20, 20, 20. This is basically 100, 100, 100, 100, which is a massive increase. And all should produce a sonic benefit. However, we have a concern that, again, when we first switch on the amp, the voltage may go over 500 volts for a short period of time. But that 500 is the rating of the capacitors, right? So in most modified Dynacos, the capacitor setup includes a few sections where capacitors are put in series to increase their voltage rating, right? So what I did, I have these hanging around. These are 220 microfarad at 400 volts. So what this is, this particular can here, which is 100 and 100, each one is in series with one of these. So this is in series with that, this is in series with that, right? So that gives us 2 sections that are 68 microfarads at, well, I'd say 800 volts, right? Because the way the voltage dividers are set up. Okay. Now that 68 is exactly what the upgrade capacitor board from this company has. They put 100 in series with a 200, roughly speaking. So also we have little resistors here, and you see the little cream colored ones. And what those do is those set up a voltage dividers to make sure that the whatever voltage is present at these sections is evenly divided between the capacitors. If 500 volts is there, then this will experience 250 and this will experience 250, right? The value of those are not really important. These are pretty big. These are 470s, but you could use anything from about 100K upwards for those voltage dividing resistors. The thermistor is right next to them. So I kind of worried about this a bit after monitored heat because this heats up. So that's why the wiring here looks kind of creative. I left the leads long and in such a way to help dissipate heat and to keep this away from these capacitors. It's much closer to the transformer. Of course, the heat will radiate upwards as well. I'm hoping that this area doesn't heat up too much. But from what I've read online, it does kind of have a localized heat. Hopefully it should be okay, right? But it is something that I will monitor. So if I had not installed these, and if I just used these as the capacitor sections, we would have more filtering. We would have 100 microfarad instead of 68. But we have that 500 volt rating, which could get exceeded on initial startup on a regular basis. And I don't know if the capacitor could handle it. So here's what's going to happen. When I get this amp up and running and I'm doing testing, I'm going to be measuring those startup voltages. And if it is that I never really get that 500 happening, if it goes up to 500 and settles back down to 450 all of the time, then I will actually disconnect these and run the can down here alone. If it is that our 500 volts is not exceeded. Other than that, I really just did everything tonight that is this part of the chassis. Okay, now I showed before that I changed some parts on this and made some corrections to some errors. And on the next board, we have a few parts I'm going to change. And they are these cement resistors, which I mentioned before. One is a wrong value and they're mounted too close to the board. And then the others are just these 4 capacitors, which are radials mounted in the way that an axial should be. Okay, so I'm just putting in new axial capacitors instead, which will give it back the low profile that it should have instead of sticking up like that. Okay, so a quick look at this board here with those parts removed, and worthy of comment here. So this had a cement resistor mounted too closely to the surface. Now, I don't know if this is bad. I haven't even measured it, but these things get really hot. And they're designed, these are called cement resistors, as I guess a nickname, but they're a wire wound resistor. And when they go bad, they often flame out through this filler area, right? So what you do when you put these on a board, you want to put them like this, not like that. You want to put the fill area to the side, so if it flames out, it flames to this side or even upward, and doesn't scorch and burn the board below. I'm not too worried about this. I don't think it's so bad that it's conductive, but it is, we definitely suffered bad practice here. So the new ones are going to have the filler side facing off of the board, right? And a few millimeters above it, floating. That's how you do cement resistors. Right, so that is that board freshly set up, and here's a look at the cement resistors the way they should be. There are several, about 5 millimeters or more above the board, and you can do it so that you can see the values. You don't want to hide the values by facing them down, but we have it so that the exploding part is on the left, right, if it flames out. Here are the new electrolytics, which are just set up so that they sit flat, so when the board's in place, they're less likely to get into the socket area and so on. Even though the tallest part is these this heat sink and these heat sinks and this capacitor here. Right, so we're done. Last point to note on this, actually, I removed, this had 2 bias level pots. I'm sure I pointed them out before. I have removed them, and I will be wiring in place of them with this 3-wire cord here, regular pots. And these regular pots are going to go back in these holes, which are the original regular spots that Stereo 70s have bias pots. Okay, another heavy work session here, but it may kind of look the same. What I've added since the last time is the output sockets. And I've added those in, done all the relevant wiring, which is really heater wiring mostly at this moment. Then linking all the tabs for the screens. Remember, this CAE Curcio mod operates the ST70 not in ultralinear mode, it's in pentode mode. So we have actually what would normally be our ultralinear output transformer taps are actually sort of taped off with heat shrink and so on. So we operate in pentode, so we're hooking up the screens, which is the blue wire here. I'm not exactly following the color code specified in this manual. I kind of doing my own thing. I have a way of doing it. I always put screens in blue, right? And then I've run all the wires for the plate connections. And I'm now at the point, I've been following along and ticking off each step because there's so many steps clearly described in this manual. And I'm reaching the point where I'm now preparing to put the board in. The board is fully prepared here with the some of the fresh parts that I showed the other day, and it's been cleaned up and so on. And that's it. I am pretty much done with chassis wiring. Right, so let's take a little break, then get into the board part of things.